Okay, so I want to keep looking at solving equations, solving polynomials, but now let's open it up to solving over the complex plane. And again, should be something that looks familiar to you, something we talked about last year in Hot 2. But again, maybe you don't remember, and that's okay. But one thing that you really should know about complex solutions is they come in pairs if you have integer coefficients, and that's key. They come in complex conjugate pairs, right? So like a plus bi and a minus bi, as long as your polynomial has real number coefficients. And that's not going to be like a huge issue this semester because that's all we're going to deal with. But next semester, we're going to start looking at what happens if you don't have real number coefficients. Then what happens? And it's actually kind of cool. But for now, just knowing that they're in pairs, and again, this whole idea of degree, so degree 3, that should be an indication that there's at most 3 solutions. It's the highest exponent is 3, so it's a cubic, and that means that most there's 3 unique solutions. But there could be just one solution with a multiplicity of 3, right? Like it could be something like x cubed, like x minus 1 cubed equals like 0. So like that would be like a third degree polynomial because the highest exponent would be 3, and there's only one solution. It's 1. But it's like multiplicity is 3 times because this is like x minus 1 times x minus 1 times x minus 1. So like each of these factors is 1, or giving you a solution of 1. So there's one unique solution. It happens like 3 different times. Okay, so when it tells you degree 3, you're looking for 3 zeros total, and they're not guaranteed necessarily to be unique, but like if we know they come in conjugate pairs, like if you know like 1 minus I is a solution, then 1 plus I has to be a solution. And look at that, there's 1, 2, 3. So there's your 3 zeros. So again, degree 4, so if 2i is a solution, so is negative 2i. Sorry, that's terrible. And then so would 3 minus 5i. Those are so solution 3 and 4. Degree 5, so here's one solution, but then there's negative I, and then there'd be 4 plus I would be the 2 other solutions. Degree 6, so negative I, negative 3i, and then there's the remaining solutions. Okay. Oh, my goodness, what happened? So then, where'd it go? Oh yeah, okay. So then it says, suppose you know something, right? You know that 1 plus I is a solution. Great. Well, so is 1 minus I, right? Because they come in pairs. And the thing is so is 1 minus I. So that's a solution, and 1 plus I is a solution. So right now that's 2. And this is a 4th degree polynomial, which means if I know 2 of the solutions are here and here, if I could somehow factor them out, get the function reduced by a degree of 2, because I know those 2 zeros, then this 4th degree polynomial then becomes a 2nd degree polynomial. And if it's a 2nd degree polynomial, it's just quadratic. And I've got lots of strategies to solve quadratics, like factoring or completing the square. And trying not to use the word quadratic formula, right? So here's the thing. So let's efficiently get rid of these zeros. So I don't know if that's going to do that or not. So we'll just erase this one more time. There it is. All right. So here's the thing. If 1 plus I is a 0, it would have come from a factor like this, like x minus 1 plus I. Right? Think about that, right? Because if you know that like 5 is a solution, it would have come from like x minus that 5. Or, 4 was a solution, it would have come from x minus 4. So the same works for complex values. And remember, we said that 1 minus I was a solution as well. So then we'd have the complex factor x minus 1 minus I. Okay. So I want to figure out what would these what polynomial or what quadratic would give you these solutions. And the thing is that let's regroup this. All right, let's do this efficiently. So if you distribute that negative, you get x minus 1 minus I, and this is x minus 1 plus I. But look what happens. Group this. Okay, so what if we group the x minus 1 minus I and then x minus 1 plus I? Like if you think about that, and I'm even going to highlight that even to emphasize that further. Like here's your first term, here's your first term, but it's like a grouping, right? So your first term, if I think about that as a group, like the quantity x minus 1, quantity x minus 1, this is like a difference of squares, right? A minus b, a plus b. And if I were to multiply that out, that's a squared minus b squared because the middle terms cancel. So if I think about it from that perspective, that's x minus 1 squared because that's this times this. Then this times this will cancel with this times that, right? The middle terms. And then we get negative I squared. So I'm just doing a difference of squares to efficiently multiply that. Well, okay. I'm a little frustrated because my smartboard's be acting crazy. Sorry about that. Okay, so then that would be x minus 1 squared. And then remember, I squared is negative 1, so it'd be like plus 1. And if I were to multiply this out, that's x squared minus 2x plus 1 more, right? Or x squared minus 2x plus 2. So I know that that has to evenly divide from my given polynomial up here because I know that it produced two solutions. Okay, now I can do one of two things. I can long divide this into x to the fourth plus 3x cubed minus 2x squared minus 2x plus 12 and get a quadratic, and that would be perfectly fine. But I can also work backwards because I know this already evenly divides and I'm shooting for x to the fourth power. So the only possible solution, if I think about what this is, that this has to be an x squared because x squared times x squared is x to the fourth power. And then look at this 12. The only place that 12 is going to come from is by doing 2 times the constant there. Well, if that's a 2 and I need a 12, I know that this has to be plus 6. And so now I'm really just like, look at that. I'm 2/3 done factoring. I just need to figure out how many x's, right? So what's the coefficient that's going to go in front of this x? And if you look up to your polynomial, there's a number of ways you can determine that. Not to mention that I'm I get that frustration. Oh, okay. So like let's look at the cubes for a second, right? So think about how many cubes do we have? We have 3x cubed. Think about where cubes are coming from, right? So if I look at this factoring problem down here, cubes would come from negative 2x times x squared. So that's negative 2x cubed. And they would also come from x squared times this quantity here. That's the only places where I'm going to get x cubed. So if I want 3x cubed and these two terms are giving me negative 2 of them, then I better put a plus 5 here because then 5x times x squared will give me 5x cubed plus the negative 2, which gives you a total of 3. So that's a really efficient way to do that. Now, let's say you were counting x's, right? So we would have obtained the same thing, right? Think about this for a second. So here's where we were, x squared minus 2x plus 2. And then this was x squared and some unknown x's plus 6, right? So we don't know how many go here. But what if you look at this negative 2x here for a second? Where would the x's come from our problem down here? Well, right now I have negative 2x times 6. So that's giving me negative 12x. But remember, I want negative 2x. So where else are the x's coming from? 2 times whatever I put here. Well, if I put a plus 5, 2 times 5, oh, that's plus 10x minus 12x would give you the negative 2. So this method of like, kind of like, I call it like smart factoring, you know it already divides, so go backwards and put in the missing pieces. Okay, so now I have x squared plus 5x plus 6. Like that, I can either factor, quadratic formula, complete the square, and I hope you don't use quadratic formula because it easily can be factored, right? So like this much right here is going to factor into x plus 2, and x plus 3. And so then those would give us the two more solutions that we're looking for. X equals -2 and x equals -3. So there's 1, 2, and remember we knew the conjugate pair, 3, so there's the remaining roots. Remember, roots are the same thing as solutions, or the zeros. Factors are if you left it in as like a set of parentheses. So like, for example, x plus 2 is a factor who gives a solution or a root or a zero of -2. Okay, so I know that, again, I'm hoping that didn't go too fast. I'm hoping that some of this does look familiar to you, but you know, we'll do a couple more examples in the next video. But I just want to kind of revisit this idea of solving across the complex plane and really to be working with numbers efficiently.